Good afternoon and good evening, everyone, and welcome to day 5 of our 9-day webinar series, Disrupt or Be Eliminated. We are really glad that we have audience from around the globe. We have people from Asia Pacific, Middle East, Europe, UK, US, Canada, from everywhere, and the response has been really very encouraging. Thank you so much. I am Bimal Patwari and will be the moderator of the webinar today. Pinnacle is the leading global BIM service provider to the AEC industry in more than 40 countries. We cover the entire spectrum of BIM construction, starting from design to construction and facilities management across all industry verticals. It is our passion and cherished mission of all 1,500 Pinnacle team members across the global offices to stretch the technology and build an ecosystem of excellence to increase efficiency, reduce cost, and meet deadlines in the AEC industry. We are grateful to our more than 1,200 clients spread across 40 countries for giving us the opportunity to work with them in the past 23 years and allow us to work on the edges of technology. Today's session will be an hour long where we will take you through our presentation for 45 minutes, and in the last 15 minutes we will address any questions you may have. So please keep submitting your questions throughout our presentation for consideration. Please keep typing your questions in the question box window. We would really like this webinar to be interactive. Right now, everybody is muted to avoid background noises that may be a distraction. So let's get started. It is my privilege to introduce our expert speakers today. Greg Walker, he is a celebrated architect and the partner of House Walker Architecture. In his illustrious career of 25 years, he has practiced in Florida, Massachusetts, and Georgia. At House Walker, he leads the firm's efforts in public sector and workplace projects with a particular expertise in workplace design, libraries, and auditoria. Kostas Pavlidis is the BIM director of Pinnacle Infotech in UAE and has demonstrated cross-disciplinary technical expertise leveraged to project delivery and high-quality design drawings and BIM technology. A keen observant of technology innovation, Mr. Kostas brings rich experience of 18 years managing large iconic projects. Friends, the construction of a commercial building represents just 30% of its cost over its whole life cycle. All the operation-related expenses make up the rest of the cost. FM constitutes 5% of global GDP. So you can imagine the importance of facility management in our economy. It is much more. Today, FM is much more than just the concerns of plumbing and lighting. FM is all about provision and maintaining of productive and comfortable work environment. The increasing user demands and complex facilities are keeping the facility managers on tenterhooks. Maintaining complex hospitals, airports, hotels, and shopping complexes is a very challenging role. Let us understand their concerns. The two pictures highlight the challenges of facility managers. I'm not sure if you have ever experienced sitting like that in the departure hall of an airport lounge. How do you react to such a situation? Most of the facilities have poor record keeping and inadequate information management systems. It could take hours to get the right drawings and information to address the problem. Just imagine the water is leaking from the ceiling and there's absolutely chaos. Today, facility managers are totally dependent on the people very familiar with the area, and they have to apply, as we say in India, the jugaad solutions to such problems. Today, most of the organizations have basements and cabinets full of drawings and documents. It is estimated that 40% of the data is stored in electronic format in progressive companies. The drawings are mostly not updated, and the as-builts available are not updated. We are presently working with some large organizations to create as-built BIM model for facilities management. And to our horror and surprise, there were thousands of clashes as we tried to make the BIM model from the as-built drawings. Most of the drawings were missing at most of the places, and our client is one of the top 3 busiest airport in the world. In the manual system, different FM divisions work in silo, and the collaboration and record keeping is not central and accessible to all. The biggest challenge is to monitor performance of assets and take preventive action. When will the pump fail or compressor fail? We will show today how advanced analytics tools can be deployed to predict failures. How can we handle breakdowns? How can we handle emergencies in minutes, confidently round the clock? These considerations have led us to rethink the way in which we operate buildings. The new process and professions will make life easier, not just for the owner, the tenant, and the service provider, but also for the end user. Have a look at this study where we see that so many companies are still dependent on the spreadsheets and paper records and the Outlook calendars and emails to manage their maintenance operations. Very few have really progressed and move up to CMMS or using the industrial IoTs. So today's key learning objectives are that, as we discussed, the facilities management is a very critical piece, and what can we do to assist maintenance and operational efficiency? How do we build the digital twin? What is the process? And what is the paradigm shift that is happening in FM and CMMS by integrating with BIM? Friends, the next step to the manual maintenance systems, where the computerized maintenance management software, CMMS, known as popularly, which has been there for many decades now. And the CMMS system provides the ability to create any type of scheduled maintenance activity. Thankfully, it is able to combine a lot of data and keep this data, and the corrective work orders can also be created as issues are reported using the CMMS system. A wealth of information is available for management dashboards and reporting by any type of criteria. The vendor and inventory modules in a CMMS system provide the capability to track all necessary information for vendors and inventory parts and supplies. Vendors can be set up including all items they supply, last quoted price, and lead items. CMMS solutions, they really help organizations to manage, monitor, and control maintenance. However, there are a lot of challenges with the CMMS system. The traditional CMMS system doesn't provide real-time data. As a result, most maintenance is reactive. Today, we cannot afford the reactive maintenances. Maintenance teams spend a lot of time fixing machines only after they are broken. In traditional CMMS system, it may help with the preventive maintenance, but it typically does not integrate with the machine sensors that enable predictive maintenance. CMMS system, they are like the DOS system, those which we have used in the 80s and 90s. before the GUI came. The CMMS system doesn't create visibility and put everyone on the same page. It still creates silos and doesn't have the graphics interface to locate every equipment and assist, which explains the importance of extending the benefits of a digital model designed at the outset for construction to building operation. I would now request my dear friend, Mr. Kostas, to launch the rocket and take us to the next orbit. Mr. Kostas, over to you.
Thank you very much, Mr. Bimal. Thank you. So, I'm Kostas Paris, as Mr. Bimal introduced me before, and we will discuss today about the basic concepts and enablers of the digital twin. What is it, a digital twin? A digital twin is a replica of the physical assets, but also the processes and the systems that can be used for various purposes, as highlighted before, for advanced analytics, for visualization, or for other processes that can enhance the process of the facility management. What does it do? It increases the collaboration with the 3D ability of visualization. It organizes the information and provides dashboards for informative decision making. We can, with the help of IoT, have condition monitoring, live condition monitoring, ability to understand and predict the futures and identify possible risks and the means to avoid them. Have scenarios, virtual scenarios, in order to find the solutions or to avoid those risks. We can continuously test the performance of our assets. We can do asset data analytics and automations with sensors and IoT. The digital twin, as said, is an environment. It's a combination of systems and processes, starting from the capture of the existing conditions that the facility is in. This can be made either with reality capture, like laser scanning, point cloud, photogrammetry, or other traditional methods. Then it's the depiction and conversion of this information to an enriched 3D model with information. So we connect these 3D assets, now virtual assets, digital assets, to persistent data and metadata with the assistance of BIM. That this enables us to do different kinds of simulations like 4D, 5D, connect to CMMS systems and allow asset management. It creates and uses a semantic model, which means that we create relations between the assets, like parent-child relations, that will enable later advanced industrial analytics. And with the help of IoT, we can enrich this data with live fed data from the sensors, and slowly moving with the capabilities of the cloud, move to the next generation of two-way data integration and interaction, with remote or immersive operations, control physical assets from remotely, and then move to the autonomous operations and maintenance with the help of robots. We have to understand that the facility, during its life cycle, it interfaces with different parts of the facility in different stages of development. A facility can start as a complex one design that then can be broken down in different contracts, which will result different stages of information. Some of the information will be in design stage, some of the information might be in as-built stage, some of the information might be in construction stage. The digital twin is there to capture and segregate and integrate all this information together and give a unique picture of the current situation. How it starts, as we said, it starts first with the capturing of the existing conditions, but also with additional data that will enrich our model and database, our information container, as said today, with as-built data, O&M manuals, product data, asset lists, installation dates, data, serial numbers, the vendor who produced the assets, maintenance schedules, lifetime expectancy, so we can allow for analytics in the future, supplier name, warranty, and so on. So the reality capture has 3 steps, as we said, in order to capture the existing conditions on site. We start either with laser scanning or photogrammetry. We capture the status of the asset. Then we have to process the data, register the data, clean, and then convert this data to a digital representation of the assets. This can be done with multiple tools like laser scanning, drones, even robots today, or wearable, movable, portable laser scans devices. Then we have the evolution of this 3D model that integrates different systems. As example, the civil, architectural systems, power systems, HVAC, fire, drainage, lighting, low voltage, SCADA, and so on. In order to be able to manage all this data, we need to have a centralized repository storage area that we call the common data environment. Because as we said, the digital twin is an environment, so it comprises for data, but we have to collect the data in a centralized area. Either these are model, spreadsheets, drawings that all reflect and give information of the asset. This centralized storage has the data structure, should have a correct naming convention, should control the versioning, should control the access and users that have access to the data, can report analytics, allows collaboration, and has other additional abilities like paperless review and workflows management. As we said, for the process of, some of the videos might not be playing, of the process of creating this digital twin, it is important to create a language of identifying first what we have to model as assets. So we have to identify the systems, develop the systems, identify the name and structure of the system with a correct location breakdown structure and product/system break structure that will allow to create unique identities for the system. We should establish the connections of the systems and the relations between them, and the interrelations between different systems. For example, the power supply to a mechanical equipment. Having this relation is essential for analytics in the future. All this data now are connected also to the information of the specific information of the assets like the maintenance manual, the material submittals, the warranties, and so on. And in order to manage those data, we use and to have the ability to communicate this data to other systems, we can use COBI. These are spreadsheets, basically, that capture the asset parameters and can integrate with different facility management systems. And they are used as a common language of integration. Furthermore, as we all know, we have to identify the unique tags of each asset, the asset tags, that should be and remain unique throughout the life cycle of the building. Having set that in place allows us then to create a fully integrated digital twin model that connects the physical asset with the replication of itself in the digital environment and the connection to the required data, and allows then to connect those assets live with sensors in the field that can fit with live data to allow for advanced analytics. These sensors might be motion, moisture, humidity, vibration sensors, and so on, that enables automations, reduces operation costs. They are operational efficient and environmental efficient and provide real data, as I said. Now I would like to pass to Mr. Bimal back the discussion in order to explain us about the value of the IT sensors in our industry. Mr. Bimal? Hello, Mr. Bimal?
Yeah, thanks, Kostas. Thanks for the nice presentation so far. Friends, as we know, a simple house today can have so many sensors for the safety and proper working of the house. You can see every aspect of our house as very clearly demonstrated, whether it's a fire sensor or a motion sensor or intruder sensor, or it's a smoke sensor, security cameras. There's so many ways. Even somebody tries to break into our house. So there are so many sensors today that we can use for our simple residential house. Similarly, as we explained, as Kostas was explaining to us, that the biggest benefit that the digital twins and the BIM-based facilities management brings is that we can actually track the live data. So if there is a pump running, and today, fortunately, most of these equipments, they have predictive analysis. If you can collect the right data from the pump, about its temperature, about the noise that it is making, about how much heated the pump is, we can actually predict the failure of the pump and take an action well in advance. So you can see that the live data from the IoT sensor can be tapped by the system continuously, and you could have thousands and thousands of sensors in a very simple plant room. I mean, there's no limit. In fact, the Cisco reports that there are almost 50 billion IoT devices that is being used worldwide today. Let's look at another example that I was just mentioning, that you have a traction motor and a very simple sensor, an IoT sensor, can measure the temperature, the current, and the vibration of the motor live. And there could be thousands of such motors in any facility. Imagine this whole data is being collected by the system, analyzed, and based on our algorithms, they can predict that which is the motor that is going to fail and how much time do we have, and we can then replace those motors well before they actually fail. And as Kostas explained in the earlier slide, when we tag the data, we tag it with all types of information. We tag it with their who are the suppliers, who are our maintenance partners, what is the part number, what is the expiry date, what is the warranty expiry date, and what are the various parts, or how do we get replaced, the manuals, everything is tagged with that traction motor. So once the system analyzes and it shows that it is going to fail, the system will automatically generate a instruction, a work order to, depending on the status of the warranty of the product, it will straight away generate the work order to the supplier or the maintenance provider to take the corrective action in a given time frame. So that is the power of IoT sensors. Kostas, I think you can take over from here.
Thank you, Mr. Bimal. I hope you can hear me. So,
yes.
As Mr. Bimal said, data today is one of the biggest drivers of the industry. It's the new oil. As a simple example, in order to do analytics, the cost relevant to the analytics in the industry, based in the German Industrial Analytics Forum, 54% of the analytics cost is relevant to the data, either getting access or aggregation, segregation to the data, obviously the analysis, but this may be not directly relevant to the digital twin, or the result visualization. So we see that the digital twin contributes directly 50% to the analytics cost by its existence alone, not even going in details of the processes that it can enhance. In facility management, in general, we know that we need 6 to 12 months to effectively gather all the data with committed manpower and resources. The single biggest factor that impacts productivity is the lack of information. And this was the answer of 30% of industry stakeholders. Also, 95% of the data we collect during construction, we don't use it during facility management, during the next steps of the life cycle of the building, during operations. So we understand how critical it is to capture correctly and manage correctly the data in order to have easy access and be able to analyze them.
Kostas, are you there?
It was muted again. Okay, can you hear me?
Yes.
Excellent. So I was saying, I don't know in what stage we were. So I was saying that the data, the IoT and the data analytics are the enablers of the Industrial 4 revolution. What does it mean? It allows now, with the new advanced algorithmic analysis tools that we have, to do descriptive, prescriptive and predictive analysis. Mostly contributes to the predictive analysis that contributes to lowering the cost of facility management. By connecting and collecting data from different sensors, inputs, different facilities, the analysis is more accurate and can have building projections of the future. Preventative maintenance It allows also obviously preventative maintenance, but we will discuss about that. That can proact to unexpected breakdowns, so lower the associated downtime and costs. It can increase the lifetime of the assets, increase productivity, improve the overall efficiency, and certainly reduce the maintenance cost. What it does, what we have to understand that sometimes we have to find the balance between preventative and reactive maintenance. Obviously, the reactive maintenance is the most costly one, though the preventative maintenance also has a cost because we might do work that is not required at the time. So by allowing for predictive analytics, we can find the optimum cost for our facility management. This increases the revenue by 33%, increases customer satisfaction by 22%. It lowers down to 75%, eliminates the breakdown to 75%, increases to 20% the production, it reduces by 35% the downtime, and the maintenance cost by 25%. This is a simple scenario to explain an analysis we can do with the data and how the model, the BIM model, and the visualization in the digital twin environment can assist us to understand the actions to be taken and how to maintain the assets, either that have to be fixed directly, or to understand what other predictive, proactive actions we have to take for other assets. So this is based on a scenario based on the model. We analyze the data, how many devices we have, how many assets. With the relation we can find and do root cause analysis. We can identify the assets that have problem, and having the percentage of them that have failed maybe before the warranty expiry date, we can predict the actions that we have to take in order to avoid downtime costs in the future. This is a descriptive, basically, analysis of a problem and allows for prescriptive analytics, defining the different solutions that can be taken to resolve a problem. In Pinnacle, we are already developing our digital twin environment, that it is in a mature level, whereas we can export, manage, segregate, and analyze data from the models we produce, optimize our production efficiency, allow for collaboration, and enable connection with future CMMS systems, and enable for industrial analytics in the future, which is our dream. This tool is already developed and used in our offices, and it's being further developed to allow integration with different CMMS applications. So the digital twin empowers us for the facility management. It allows us easily to navigate and find assets on site. We can use mobile applications to do predefined inspections on site, sync the data live with the BIM models, automate and tabulate the data, have a manageable equipment database, live asset start reporting, and issue analytics. The mobile inspections, though not used by more than 50% of our industry, is proven to lower the hours required for inspections, per 100 inspections, by 93 hours per 100 inspections. It requires 25% less hours, and this is only the tangible, direct gain we have by the use of mobile inspections. Obviously, by allowing to the connection of a database, it allows us for analytics, reporting, dashboards, better explanation to our customers, and visualization of the problems. This is a replica, an enabler for the digital twin, a 3D model that we developed as Pinnacle, enhanced and enriched with all the required data for all the elements, in order with the application we saw before to allow to the link to either facility management systems or do in-house analytics as required for us. In addition to that, as we said before, the digital twin gives us the possibility to do different simulation scenarios and visualize them rather only report them, like the maintenance route, actual maintenance simulation, before we actually do the real maintenance on site, to identify possible risks, hazards, scenario simulations based on occurrences on site, to identify the reactive measures and corrective measures to be taken in any breakdown scenario on site, and at the end to assist us with VR assisted maintenance in the future, and actually is happening now, linking the maintenance to the digital twin and virtual access, direct access to the data, where we can visualize, see the products required for maintenance on the site, identify the parts to be replaced, and give guidance to the engineers on site how to do and maintain the assets. I would like now to pass to Mr. Craig for him to talk about our project of the ASHRAE headquarters in US. Hello?
Yep, hi, thank you. And I'll start by saying, where we're really excited as the architects on the ASHRAE project to be working with you all in creating a digital twin here. As most of you probably know, ASHRAE is the organization that helps set the standards for heating, refrigerating, and basically your air conditioning systems throughout the globe. They help write code standards, energy efficiency standards, and they were helping or needing to create a new headquarters building. And one of the interesting things and compelling aspects of this project that we found as the architects was that they were really committed to trying to have this be an example project or a kind of model project for how we can retrofit existing buildings to make them energy, high performing from an energy standpoint, net zero in terms of energy consumption, and to do this in a way that was replicable both by the technologies involved, but also by the cost. So The building that ASHRAE found, as you can sort of see here, was a 7,300 square meter existing building just outside of Atlanta, Georgia, which is where their current headquarters is. And we began as the design team by coming in and trying to create an exhaustive existing a model of the existing building inside Revit, so that we were working inside Revit throughout the entire project as our BIM choice. And we had to model a number of different aspects, including infrastructure, the structural framing. We also had to do extensive modeling for the local climate to help figure out how could we get this to net zero energy consumption. And so for those of you that don't know, Atlanta, Georgia is a climate region 3A, which means that we are hot and humid. And in practical terms, that means we have 5 months of summer, about one nice month on either side of that, and then we have kind of an extended fall and winter season. So it can get quite cold, but it can also be like today and be well over 90 degrees Fahrenheit. So we had to monitor, what would it do in the winter, what would it do in the summer. And to the point of this seminar, we were using a lot of advanced analytics throughout this project to help both understand what we needed to do in terms of accounting for shade and solar orientation and heat gain on the building, but also to help think about how are we going to maintain the building over a long time. One of the key drivers that ASHRAE set to the design team was to develop what is for Georgia a fairly low energy use intensity. And so you can see here we have a little note that says target 21.4. ASHRAE had mandated to us that they wanted to get the energy consumption to be below 21.4, which was a little under half the baseline model that we were starting from. And so this really wouldn't have been possible to achieve unless we had a lot of advanced analytic data that we could program into the building model to analyze how would we get here. Right now the project is on track to achieve a 20.8, so we are going to fall under that 21.4 target. So how we got here, and you're starting to see some of the renderings that Pinnacle has developed for the digital twin that they're building of the building. How we got here is we had to, in order to kind of meet their cost targets, we really had to take the existing structural frame as is, but we redid the entire exterior envelope to make it more high performance oriented with a combination of exterior insulation systems and high performance glazing, and also a combination you can kind of see here of solar shading fins that were very carefully attuned both in size and configuration for each facade. And then on the interior, one of the other key aspects that ASHRAE asked us to do, in which we did hundreds of simulations on, was to examine how could we get daylight into over 57% of the predominant workspaces, meaning we would have more than enough daylight to basically turn off the lights for 57% of the entire space. And so to do that, we modeled a lot of different configurations with the glazing, trying to keep the exterior walls at a reasonable percentage. And then we also introduced a number of skylights on the uppermost level. So as we kind of go forward, and we are currently in construction, we should be finished with the project in late September, early October. One of the key things that ASHRAE wanted to do, and I think I can say they were really excited about when we began the conversations with Pinnacle, is that they wanted to create this digital twin for a lot of the reasons that Costas has gone over in here in terms of maintenance and ongoing facilities upkeep. They also wanted to be able to provide, though, an online digital tool that is an education opportunity, so that for members of ASHRAE or the general public that can't come to the building and see how it's working in person, they wanted this digital twin to be able to provide that kind of virtual experience online, so that you can come in and understand better how is the mechanical system developed and how is it functioning, and see online live dashboards that's gathering all the data for the performance of the building as it's being operated, and be able to send that back out publicly at all times on their website. So this is, and I may ask Chip to kind of help me jump in here in a minute, but this is the preview, I think, of the digital twin that is being developed by Pinnacle. And again, we're trying to create something that both reflects the final as-built conditions as well as the design parameters. And we want to be able to, from a design perspective, have everybody be able to have a good, digitally simulated experience of what it would be like if you visited the headquarters in person. So we've been working with them to help get refinements made. And I think one of the key features you'll see in a second, and I'm going to let Chip talk to, is how we were modeling, or Pinnacle was modeling, the systems diagrams and system configurations, again, to allow anyone to be able to kind of come in and understand how the system was put together. So Chip, you can speak a little to that.
Yeah, thank you, Greg. This is Chip Branscombe with Pinnacle Infotech. And yeah, I'm really excited that we were able to be part of this project, working with Greg and the entire design team. And like he said, it's really meant to be, I think, part of Chuck Gullidge's vision, the new ASHRAE president, is this to be like a living laboratory, right? Because ASHRAE, being such a global organization with the standards, the technical expertise, that this is an opportunity that no matter where you're at, anywhere in the world, you can come literally fly through this building and understand the latest, and like Greg pointed out, how net zero was the target, the goal, right? How energy efficient this building is using the latest technology. So yeah, it was an exciting project. I was glad to be part of it. And again, the digital twin, there's so many opportunities. Working with this process was taking an existing building, so we worked with Greg and his team's Revit model. We implemented his systems with the mechanical, the fire protection, and we basically integrated all of that to create this walkthrough digital copy, so to speak, of the existing building. So exciting project, and lots more opportunities for future buildings, and as Bimal and Costas and Greg, everybody's been talking about, that there's so much opportunity here with information and how we use it to just improve everybody's life and energy savings.
And with that, I think we're going to hand it back to Bimal for questions, and thank you again for having us on to participate.
Thanks, Greg. Thanks, Chip, and thanks, Costas, for a very detailed and informative presentation. And I can see there are a lot of questions from the audience. The first question is from Craig. The question is, I think I'll put it to Costas. What should be the workflow to move to digital twin? And what are the challenges you see in the process? So, Costas, would you like to tell a company, if they want to move to digital twin, what should be the workflow? I mean, how should they move to it? Costas, you are muted. You'll have to unmute yourself. Okay, I will pass it then to Chip. Chip, can you explain to us that, because you are working with ASHRAE to move them to digital twin. So if there is an existing facility which is now being run on a manual system, so how do you suggest them to move to the digital twin? What should be the...
I think the workflow, the question about the workflow is really, it's dependent on the ultimate goal, right? For ASHRAE, it wanted to be more of a living laboratory and integration of the facilities management. So if you're a hospital or if you're a school, facility, industrial, commercial building, everybody has a different objective, right? So I think the workflow is to begin with the end in mind, right? How do you want to use that? Is it specifically for facilities? Then if that's the case, you start with your mechanical and your controls contractors, your security access contractors. I think you look at the workflow on how you use that data, right? And then I think the challenges are getting the information earlier in the design process, right? So that you don't have to go back and recreate or duplicate it, right? So if you know this is what you're going to do with it, the integration with the end user, the owner or the facilities management team, and the actual installation contractors, the controls contractors, the commissioning team, I think everybody has a chance to work on that. So it's just a matter of identifying those goals and objectives on how you want to use that. Is it just for public PR marketing to show your shareholders, or is it for the maintenance predictive aspect to say we want to be able to replace these pumps at the end of their life cycle and not have a catastrophic failure?
Thanks, Chip, and it does make sense, depending on the end objective you could be doing. And as Costas explained the whole process, that how do we digitally first capture, then we process it, then we convert it into the intelligent 3D model, and then we add all the data, all the system connections, and as Chip explained, all the related suppliers need to be combined, and finally, depending on our end objective, we design the whole system. The next question is from David. He is curious about the costs involved in the process. And I'm sure this would be one of the most important questions before any management to take this big leap. And, still it is there are not many people who have really done the full digital twin processing. But as Pinnacle has been helping some of the organizations, and I can share some of the costs that we are doing for some of the projects. And obviously, and most of our projects, the clients want to use it for actually facilities management. And one of them is an airport, and one of them is a big, car park. And there's another one facility that for a university, we are doing the same project where they are again scanning and creating the live model. So again, the cost varies depending on the complexity of the building, the size of the building, and the relative availability of the data. But I would say that if I look at the cost, it varies from 30 cents to 50 cents per square feet, and that includes the process starts assuming that you have and this is for an existing structure I'm talking about. So it's an existing facility, and if you have the as-built drawings, and obviously we don't expect them to be all correct. So we take the as-built drawings, we laser scan that, or we use other tools to capture all the data, the as-built data. We create an intelligent model. We include all the databases of our COBE data, as we explained, for each of the assets that we want to maintain, and create a final product which can be integrated with the CMMS. So this is the cost that I anticipate. So if you have a 1 million square feet facility, your cost would be anywhere from $300,000 to $500,000 US dollars. Again, it will, as I said, it will depend on the country, because the rates could be different in different countries of scanning and But then the good thing is that most of the things can be done offline. So you just need to be scanning the data on the site, and rest of it can be done offsite. So that really helps to reduce the cost because it can be efficiently done at different places. Okay, the next question is from Rob Lee. His question is, what type of communication systems are required for live data? Yeah, Kostas, you would like to take this question? I see that you are now unmuted. So what kind of communication systems are required for live data? Kostas, can you hear us? Anyway, Chip, would you like to enlighten us on that?
Can you hear me now?
Yes, we can hear you.
I would allow Chip to speak because I'm not an electrical engineer and it's not my expertise, the field of my expertise. Sorry for that. I can tell you how to enable the process, but not go to the actual engineering of an electrical system.
Well, the live data, if you think about it, we've always had that for most buildings for the last 10, 20 years. It's through the building automation system, the temperature controls, the direct digital control systems. So the live data is there. What I'm learning from this process working with Ashray and Greg and the design team is now that we've got all of this information and we're all kind of getting together to say, okay, now what do we do with this, right? So the real question is exactly what you ask. How do you communicate or how do you share that information? One of their dream requests was, hey, wouldn't it be great to walk into the building, pull out your smartphone and use it for wayfinding to say, I've got a meeting in conference room 3 on the 2nd floor. And it could show you how to get there, maneuver you through the building. So the question is, what do you do with all of that data? Because it could be used for good or it could be used for bad, right? Do you put the security access control on the open web that it's accessible or it could be hacked? Do you want them to see your cameras? Do you want them to understand where the access control points are or the security doors? So that's an interesting challenge. And it goes back to me as some of those different silos, right? That the HVAC temperature controls contractor can control all the HVAC systems, right? If they want to put the meters on to do water management, sanitary, solar photovoltaic, how much energy are we making or putting back into the grid? But then the other control system, you have lighting control systems, right? That's a separate little system. It usually doesn't talk to the building management system, but it can. Same thing with the access and security control. Does Greg's badge get him in the 2nd floor and Chip's badge doesn't, right? So all of that information's there, but you just have to pull it together and then figure out now how and who do you give access to? So I guess the answer to the question is it's multiple systems and each one's different. Honeywell, Siemens, Automated Logic, everybody's proprietary to a certain extent. And it depends on who you have for that building and what their capabilities are.
Thanks, Chip. The next question is from Bip, and he's asking that for an existing facility, if you already have an existing facility and you are building the digital twin, how do you integrate the IoT devices and the sensors because it's already an existing facility?
Well, again, it's back to the open protocol, the BACnet that Ashray has developed years ago is the communication, right? What information do we need to extract? Because we can extract any information. It's just a matter of the IoT device, so to speak, to let us grab that. So we can, a fire alarm system, temperature controls, whatever the system is, you just have to work with that vendor or that manufacturer. Because they're doing it now for off-site remote communications, to send a text to the facilities guy on vacation to say, hey, they have a valve failure for the CEO's office. You might want to get on that. So you just have to work with the existing temperature controls building automation system. So it's possible. And if not, it could always be upgraded. And then when you upgrade, you've got a lot more opportunities to do that interface.
Thanks, Chip. There's another question, and I can see the audience is really curious to know if the technology has matured and it is ready to be implemented, or still it is on the trial stage. So, any comments on that, Chip and Kostas? What are your experiences in the industry?
The technology is there, Mr. Piman. It's a question of collaboration and coordination between the vendors providing the technology, because as Chip said, okay, one aspect is the security of the data communication. The other aspect is the ability of the vendors to collaborate and integrate, because as the digital twin is an environment of systems that have to integrate and talk to each other, you need the vendors to integrate the system to a centralized system and allow APIs to extract, communicate, and exchange information. So, yeah, Chip, please.
Yeah, I agree. The technology is there. I think honestly it comes back to the owner, right? The owner, is it a sophisticated owner that recognizes the value of that? It's what I call, you mentioned the cost of creating that digital model. I look at it as the life cycle cost of that building, right? Many buildings, developers or owners just want to build a building for a very specific purpose, and they're more interested in the first cost. How much does it cost me to build this, right? And not many, now I think it's happening more and more, but years ago, they weren't so interested in the life cycle cost of that building, right? If I use the good, better, best, maybe the carpet's good enough, but what if I use the best carpet and I don't have to replace it in 6 years or maybe 10 years, right? So I think it's the sophisticated owner that says, I want to make this investment because I know it's going to pay off now and 10, 20 years in the future, give me a much better building, and I'm going to save, not just looking at the first cost. So the technology is there. I think it's the desire of the owner to say, I want to implement this. I want to use this. I see the benefit.
Very interesting thoughts, Chip, and you are right, and when we look at the benefits, the preventive maintenance, as Kostas was saying, the breakdowns that you can avoid, the predictive maintenance and the reduction in the cost of maintenance, the availability of data, I think if you look at the total and how much it can affect your production, if it's a pharmaceutical company, if it's a hospital, can you afford a breakdown? If you're an airport, can you afford a breakdown? Can you afford a ceiling leaking at the departure hall? So this is a big call that we need to take, and I think the way the technology is moving, the way the software is getting more sophisticated, the hardwares are getting more advanced, the costs are reducing, and today when I look at the costs and the benefits, I think the benefits far outweigh, and the success stories that now are being created all around the world with the implementations will definitely encourage more and more people to come forward and implement this technology. Greg, you'd like to summarize? You'd like to say anything before we end the session, because we're already overshooting the time? Would you like to say something from ASHRAE perspective?
Well, what I would say is that one of the things that we've touched on here that was really unique to this project and kind of ties together some of these questions about how much data do you gather and how do you integrate that into a larger narrative. Going through a project like this, one of the things that's real easy to say is that we needed to get a lot of data on the performance of the building systems. And on top of that, though, one of the other aspects that we really haven't talked about much is how are we using the data, though, to improve the everyday work environment. And, in another seminar that might be kind of interesting to explore, but we use a lot with daylight sensors and thermal comfort sensors to really help drive how do we make the workplace in this instance as pleasant and productive as we can. And so, to me, just being able to see more of this technology embedded in the buildings as a designer is really fascinating, because I think we're all about how do we get that feedback, and how do we then use it to perform all of the different tasks that owning and operating a building entails.
Thanks, Greg. And I think this is a great initiative by ASHRAE, and it will help to build confidence in the society, in the industry, about the importance and the benefits and how easy it is to implement this solution. So once again, I'd like to thank all of you for such wonderful presentation and the interaction. I'd like to thank our audience who have been very patient, and they've been asking questions and taking part and encouraging us for this webinar. And I'm really delighted to tell you that many of the audience that we have been participating every day. This is the 5th webinar. We thank them for their support, and we promise to you that the next week we still have 4 more webinars, and we're touching the entire spectrum of the AEC industry. And we look forward to your feedback. Please do give us your feedback so that we can improve on our presentations. We can include more topics which are close to your heart, which you'd like us to talk about. And so thanks, have a nice weekend, and stay safe and take care, my friends. Thank you. Have a good night.
Thank you very much. Have a good night, everybody. Stay safe.